Hi guys, welcome back. We are now in week 3, so we are now at the midway point of the Direct Access Music Production Workshop. Let's kick off today. Right, as usual, we'll start off with some of these, going through some of these notes and some of these slides first. I hope you all have gotten. I've sent you all the copies of the previous week's one, so you can always look it back. Look back and refer to it as for your own reference, lah. Okay, cool. Let's get right into it. Okay, so. Now, introduction to music hardware. Okay, so you can see as this picture shows, this is a very, very famous photo. Okay, for those of you who are absolute like studio and tech geeks, this is a very famous photo. Do you all know, anyone know who this is? No? No idea? Okay, right. Like his name is Jack Joseph Puig, all right, and so this is his studio, all right. It looks like the like a control room of some kind of a starship. Nowadays, we work kind of in the digital domain, lah. All right. The fact is that moving forward, right, the DAW is here to stay, lah. But somehow there is still always a place for analog hardware. We still find it desirable. We still find a lot of our favorite music and a lot of the biggest records that are still mixed to this day, a lot of it's still being done, either recorded or mixed on, right, on a large format analog console, of course. But it's important to know because how your DAW works, right, how your signal flow and everything works, the concept of how everything is arranged inside a DAW, it takes its inspiration from actual analog hardware. Last week, I mentioned about the introduction of the VST technology, virtual studio technology. Basically, they were trying to sort of emulate how, the pieces of real world analog hardware, they try to, emulate and replicate it so that, inside a plug-in form, like in a digital form. Now, you may or may not be using, a lot of actual analog hardware, but I still think to this day it's still very important to at least know and be familiar with it. Because once you know that, you will know your DAW, you will know how signal flows it works inside a DAW. Not necessarily vice versa. If you are someone who is just on DAW, not necessarily you will know the other way around. Okay. But if you know analog, digital makes sense. Let's go straight away into it. First thing that we should know very quickly, let me run through this. Filters and equalizers, okay? So this is going to be something that you will all definitely be using, all right, in your recording or in your mixing. First things first, the common types of filters are, right, you have 4 of the most common types of filters. As the name implies, filter, right? Filter means that it will allow some things to go through and it will prevent other things to go through. In this case, we're talking about frequencies. So as you can see from left to right, the various diagrams, first one, we call it the high pass filter. And this is probably the one that you will encounter most commonly, okay? So doesn't matter whether you're an analog guy or digital, right? Whether you do everything inside a computer, high pass filter is almost there, right? In a lot of situations, and it's the one you will use very, very often. High pass, inversely, the other way around, you can also call it low cut lah, okay? Because that's what it means. It allows the high frequencies to pass through, okay? And it cuts all the lower frequencies, okay? So that is a typical shape, all right, of a high pass filter. Okay, now, so the opposite one is called the low pass, right? So that will be the first diagram over there. Low pass allows all the frequencies that are lower than whatever the cutoff point is set, okay, to pass through. Moving on, band pass. Okay, so band pass in this case is actually a combination of the two. When you mix in a high pass and a low pass filter, you get what we call a band pass. Now, band here is not talking about band like a 4-piece band, 3-piece band. We're talking about a band of frequencies, okay? So when you sort of see it's a combination of a low pass and a high pass, you get a bandpass filter. So, you can narrow it down to a certain specific range of frequencies that will only pass through. So, as you can guess, the fourth one, it's kind of the opposite. It's the inverse, okay, of the bandpass. Now, we call this, right, the notch filter, but as in this diagram, it also describes it and calls it as band stop. The notch filter, technically in this case, all right, what it means that it is allowing the frequencies below and above, you see, to pass through. And what it does, it cuts a very, very narrow band of frequencies. All of them will have, their use in certain applications. Filters, so that's filters. In a low-pass filter, frequencies lower than the cutoff frequency are passed, okay? Frequencies higher than the cutoff frequency are cut off. Now, in the case of a high-pass filter, frequencies higher than the cutoff frequency are passed. Frequencies lower than the cutoff frequency are cut off, okay? So I explained that earlier already. Moving on. Okay, next thing, EQ. All right. We always use the word EQ. We say bass, mid, treble. But there are actually several types of EQ that we need to know. And also, once we know that, we know how to apply and where to apply it. So what's the definition of an EQ? Right. EQ is short for equalizer. So equalizers or EQ is circuitry or software that's used to alter the frequency response of an audio device. EQs generally, equalizers, there are two types, right? You have what we call the peaking or shelving, okay? Now, as the name suggests, all right, so the name describes the frequency response. You have peaking and then you have a shelf, right? So it shapes the frequency response in its own way. Let's look at the first one. This is your peaking EQ. As you can see, you either have a peak, a positive peak, right, or a cut or a dip, right? So that's the reverse. Like if you attenuate here means if you cut the frequency, you get a dip. If you boost it, you get a boosted peak. Now shelving looks like this, right? So shelving looks like your cupboard shelf, right? Or the shelf, wherever your kitchen shelf or whatsoever, a shelf looks like that. It's not generally always flat. Sometimes it can be a curve, but generally that's what a shelving filter looks like. You can either have a high shelf or a low shelf. High shelf there affects the high frequencies. Low shelf will affect the lower frequencies. So you have those two types of EQs, right? Generally, you have your peaking, you have your shelving. Now there's also one, right? Okay, type of EQ that actually I think a lot of it is very, very familiar. The graphic equalizer, okay? So a graphic EQ has individual slider controls, right, for a given number of bands, okay? So you have a 31 band EQ. Sometimes you have, on a guitar pedal, sometimes it's less. You like 7 band EQ, 14 band EQ, and so on and so forth. So it provides a visual representation. So it's easy to use because you can sort of visually look at how the frequency curve is when you set, right, the settings. Right. So this would be a typical graphic EQ, right? You have stereo, sidetracker, right? When you say stereo, you are correct, but it's not necessarily stereo. You can also use this in what we call dual mono. Maybe you run 2 mono channels through it, okay? So it doesn't always necessarily have to be, when you see something, 2 channel, means it's a stereo thing. It can also mean dual mono. Okay, moving on. What we will use kind of a little bit more commonly, right, in a studio application, what would be this. So if there's an EQ which allows the full parameter adjustments, okay, of your center frequency, right? What frequency you want to adjust, how much of the boost, how much of a cut, and also the bandwidth, right? Bandwidth, we usually use the unit, we refer to it as Q, okay? There's actually a mathematical formula for it, right? Again, don't need to go into details of mathematics. So if you have something that can you adjust all the parameters, we call it a parametric EQ. Now, opposed to as earlier, graphic EQ. Graphic EQ, you cannot change the bandwidth. Bandwidth of all the knobs, the sliders are fixed already. Frequencies are also fixed at those certain frequencies. You can only do a boost and cut. Okay, so this diagram kind of shows you what are the parameters when we talk about frequency response curves. You have, right, your center frequency. So in that case, F0 in this case is labeled here. That's your center frequency. The boost or cut the depth, right? In this case, you can see this shows like a 12 dB boost at this particular frequency. And you have something what we call the bandwidth. So bandwidth in this case, again, as I said, there's a definition, right? It's not necessarily everything from the bottom there, right? Not the bandwidth. There's a certain range where we actually measure and calculate the bandwidth. Okay, let's talk about some of the music hardware that we're going to encounter, right? And what I'm going to sort of focus on is basically the mixer. Now, or mixing console or mixing desk, whatever you want to call it, lah. Okay, depending on where you're from, right? In this case, let's just call it mixer, lah. How many of you guys, right, have your sort of a basic home studio setup? You guys have, right? Everyone? Yeah. Even though nowadays a lot of things, as I mentioned earlier, it's going into your computer digital realm, right? Everything can be done within a laptop. You can route all your signals, everything, internally, even your interface also. The software usually comes with they come with like a software mixer where you can always route signals and balance it. I still think, and I really highly recommend that for your setup at home, it's still very, very useful and very versatile to have at least some kind of a small mixer, a small format mixer with maybe 3 or 4 channels or something like that, right? Because a hardware mixer is going to save you a lot of time, actually, right? When it comes to, connecting stuff, when it comes to maybe if you need to patch in extra devices or extra instruments, having a mixer, I tell you, it's really, really handy. If you want to set up monitoring, yes, definitely you can do all of it within the software realm. Or if you want to, control your volume, monitor volume, for example. But it's so much easier to just go and take a cable, patch it in, turn a knob faster, right? Than having to go inside the software menu, you use your mouse, drag and then adjust all that, right? As you can see, which I do when we do our recording sessions. So much faster if I have like a actual hardware mixer in front of me and pop, 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 do the routing, all that. It's a lot faster and it saves a lot of time. Okay, so that's why mixers are not going away. We still see that still very relevant to this day. Okay, now let's talk about mixer. All right, okay, so there are 3 primary functions, all right, of a mixer in a sound system. Let's go quickly through them. So number 1, obviously, all right, it's called a mixer. So we are mixing the various inputs together. Whatever the different inputs, we mix it together, right? We combine it, then we send it out to wherever, right? It could be a concert PA system, it could be it could be you sending it into your DAW, whatsoever. The second function, and which we're not really aware of it, but this is actually very important. Okay, you're taking all the inputs, whatever inputs you get. It could be an instrument, could be a microphone, could be a DI, and what the mixer actually does, it actually converts them into the appropriate line level signal. This is very important, right? Converting into a proper level, into a proper line level. Once you have proper line level, that can be sent to your DAW. It can be sent to your converters and all that, right? Because again, this is again another topic which we'll cover again later today. I'm going to talk about meters and operating levels. And then, as I mentioned earlier, right, it's a center control. You mute, right? If you want to mute certain inputs, you want to group certain inputs, right? And you can select, right, whatever your inputs and outputs are. So that's basically what a mixer can do for you. These are the 3 primary functions. Now let's talk about the basic building block, right? So this applies also, right? Almost all DAWs, when you open up the tracks, how they sort of arrange the concept of your inputs, and then when you open a channel strip, it's going to apply the same way, right? So if you understand this, okay, if you understand the channel strip, you will understand whether it's analog or digital, basically, okay? how the signal flows like. Firstly, first component in a channel strip, all right, is always the mic preamp, right, or mic preamplifier. So there's a typical diagram of an actual right hardware of a mic preamp section, lah. Okay, so it's usually always starting at the top. Later, you can always go and take a look into the at the mixer inside. Right, you can take a little bit closer look at how it's actually laid out. So one thing that a lot of people are kind of sort of confused is that they're not aware that actually a mic preamp is everywhere. Any device you have that you can plug in a microphone or you can plug in anything, you got your mic preamp ready. Because sometimes like I encounter questions, they say like, do I need to buy a mic preamp? You actually have one on your interface. That's your mic preamp ready. Okay, so it's just a question of whether it's a built-in one, right? In that's built in already to your interface, or whether you get like a standalone, like a external mic preamp. Obviously, an external one is designed and built specifically for that task. It's usually with better quality components, better quality everything. All right. So generally, what's the job of a mic preamp? It's called a preamplifier. So amplifier means it's used to boost a signal. So a mic preamp is used to boost a mic level signal that's coming into the XLR input to line level. So remember the primary function of a mixer. You want to bring all your low level different signal levels right to a line level. So line level is a level which the device can process it. All right, so now mic preamps may have what we call the phantom power. Okay, so phantom power is usually nowadays it's standardized, right, as plus 48 volts. So this is to power condenser microphones. And of course, you can also use to power active DIs, okay, right, as I covered right in the previous week, active DIs. So the main control here is the preamp gain, how much gain we need to apply. Move on. Yes. Okay. Almost forgot. Usually, right, very often you will find that in the preamp section, you will all have a high pass filter. Let's move on. Next section, you have your EQ section, right? Either you have your shelving, you have your parametric, or with most of the analog mixers, you have what we call a semi-parametric. So semi-parametric here, usually it means that you can't control all the three parameters. So generally what you can control in those situations would be the frequency and the amount of boost and cut, not the bandwidth. Okay. If you have a console, obviously, which has a fully parametric EQ, of course, that's great, right? But usually it will cost a lot more because your circuitry is going to be a little bit more complicated, a little bit more complex than that. Right. So most of your average mixing consoles, if they have like maybe 3 or 4 bands of EQ are, the mid band, right? Usually the mid frequency would usually be the parametric or semi-parametric. Typically your high frequency band on your mixer is usually going to be a shelving. Same goes with the low. So the high and the low frequency usually will be shelving. Your mid frequency will usually be a parametric or semi-parametric. Auxiliaries, or in short, we call them auxes. What's the role of auxiliaries? So usually we refer to the auxiliaries as your aux send, right, or aux return. So the word auxiliary means that it's additional. These are actually not your main inputs or outputs. These are additional inputs. It's just extra inputs and outputs. So there's nothing special about it. It's just extra. That's all. So what are the uses? Now, so the most common usage, right, is for sending a signal to an external reverb, right, or an effects unit, a delay or whatsoever, right? You send it out to a reverb, and then the return from the reverb is fed back in the mixer. Same kind of concept, all right? If applies whether it's inside your DAW, same thing, right? You send your an aux send to an effect, a reverb or something like that, and then the return sends back, right, and is mixed back into your audio. Now, in live sound, for example, in a concert, it's used to provide your monitor fallback, okay, stage monitoring, basically, okay. Whether it be via, your monitor wedge speakers on stage, all right, or headphones in the studio. And of course, now, all right, a lot more common nowadays, increasingly, right, in-ear monitors, IEMs. As mentioned, okay, these can also be used as extra inputs and outputs. For example, if a mixer says that, It has 8 channels, for example. It's 8 channel. It only have a stereo output. At first glance, you may think, oh, this mixer, alamak, only got stereo output. Your master, you can only output 2 channels. Actually, that's not necessarily true. You can actually have more than that. And how you achieve that is through your auxiliaries, lah. So again, depending on how many auxiliaries they have, you have 2 auxiliaries, or sometimes, bigger mixers like that will have up to 4 auxiliaries. And if let's say they have groups, right? If you have a group outputs and group sections as well, you can actually have sometimes more than your 2, right? If you're very clever about how to route it, lah, okay? How to sort of route and send a signal. Some also will have what we call, some mixers will have a direct output as well. So if a mixer has a direct out, that's even more handy, more useful. So many more outputs, all right? So now auxiliaries. So here's very important, okay? So even in the digital DAW also, it's very important to understand the concept of pre-fader. What's pre-fader? Pre-fader means that your auxiliary is going to be before your volume fader. Whatever you change, right, with your fader level, with your volume fader, it does not affect your auxiliary. It's because it's it's before the fader, you see? It's before the volume fader. So whatever changes you do is not going to affect that auxiliary aux end. So that's going to be very, very important. Now, the opposite is what we call post fader. So if your auxiliary is, being taken, you're tapping the signal after the fader, what happens then if you change your fader volume? It changes the level of whatever's being sent out to the auxiliary as well. So you got to know where to apply something pre, or where you want to apply something post. As it says here, in pre mode, the signal sent to the aux channel is taken before it passes fader controls. In post, it's taken after. I'll just give you two real good examples. Now, in live sound, for example, monitoring on stage lah. Usually, for monitoring, we put it pre-fader. And the reason why, anyone can give me an answer? Why, let's say on stage, your stage monitors, we send it via the auxiliary, and it's usually almost always pre-fader. Answers? Anyone? Come on, don't be shy. If you know, don't be shy.
You want the signal to stay the same.
Mm-hmm.
When you adjust, it doesn't.
So it doesn't affect the stage monitor, right? Yeah. So that's right. Exactly. If you have it pre-fader, so what this means is that if you are, let's say, doing like a live sound for a concert, so the sound engineer is, adjusting the balance of the levels, right, so that it suits, it sounds right for the audience, lah. But if you do that, right, and if it's post fader, what happens to the singer or the performer or the musician on stage? Hey, suddenly their volume also change, you see, right? So once you set a monitoring level for the stage, you want to keep it at that. You want to keep it at that. So whatever you do, whatever the sound engineer does to balance or to mix it for the audience or for broadcast, nowadays, right? That's very important nowadays. Broadcast mixing has really exploded this past couple of months, right? The need for engineers to do broadcast mixes, right? This is really, really grown a lot, lah. So it does not affect what the performers or the musicians hear, you see, on stage. Same goes also when we're recording, like, if we're recording drums or if we're recording a singer, whatever we do when we adjust our levels, we don't want it to affect whatever the singer is hearing in their headphones, you see? So the other way would be, let's say, in a situation when we are mixing, let's say in the studio, we're mixing a track, we're mixing a song. In this case, right, your auxiliary sense would typically be a post fader. And now, do you know why? Come on, answers. You guys got an answer for that just now. So, how about in this situation? Let's say we're sending to a reverb. Okay, why is it post fader?
You don't want just the volume too slow. You want the reverb also.
Technically, yes, right? But what we're talking about is the signal that's being sent to the reverb, right? Yeah. So in this case, Let's say if you want to mute the channel, you turn the volume all the way down. Okay. What happens if it's pre-fader? Suddenly the reverb is still there. Okay. Now that is definitely going to be weird lah. So in mixing, when we are mixing, right, either inside the computer or we're mixing for an audience or anything like that, when we talk about effects, if we bring down the volume of the vocal, for example, we want the reverb to correspondingly also come down accordingly, lah, right, with the same amount. So that's why you route something pre or post. So in this case, we route it post. So you guys are clear? You understand, right? Where the application of a pre or post is. Okay, we cool? Okay, let's move on then, right? All right, pan control. Okay, very, very basic, very simple, okay? Full name, right? And the full technical name is very long, okay? Panoramic potentiometer, okay? Or pan pot for short, right? Panning lah, okay? Let's just call it that. So it's used to adjust the stereo location of a sound heard through your speakers or headphones lah, okay? Obviously, now you have 5.1, you have surround sound, you have binaural, you have ambisonics, you have all the newer, right, immersive audio. So panning, right, goes way beyond stereo already nowadays. When you say something is pan hard left or hard right, it's basically meaning that the balance, right? It's actually a balance between your left and right speaker. So if you say something hard left, it will only be heard in your left-hand side speaker, lah, right? And same goes when you say hard right. So when pan to the center, the sound will be heard equally in both speakers. And this is kind of going back to your question last week, right? When we talk about stereo, how we sort of determine and hear stereo. Okay, when something in the center, the volume that's coming out from your left and your right speaker is exactly equal. So when you hear it exactly equal, we hear it, right? Our ears and our brain will perceive it as poop, dead center lah. You can also achieve it by having just one speaker in the middle, right? But that's a different scenario lah. That one is more of when we talk about 5.1 and surround sound, okay, where they actually have a center speaker for dialogue. Mute control, obviously, okay, when you have the backing singer is Sumbang, where singing out of tune, mute, okay, or the guitarist is like playing some out of tune and then soloing like crazy on top of a slow ballad. Okay, mute. Right, your mute button, right, can be a very very good friend. Okay, it can also be your enemy also. Oh, you forgot to unmute something. Alamak, right? You also have what we call the solo. Right. In this case, right, when we talk about on an analog mixer, right, on a real mixer, very often you will see this PFL. What does this PFL stand for? Anyone knows? Okay. PFL is short for P, it stands for pre, fade, listen. Okay. So you can think of it as the same thing, right? Solo, right? But in this case, a PFL is for a pre-fade listen. Okay. Now, there is actually some technical difference between the two, right? So when you solo when you solo a track or you solo a channel, right, inside a DW, so when you solo it, yeah, you hear only that channel lah. Okay, so that's fine. Okay, inside a studio situation when you're mixing, yeah, that's cool. That's how we expect a solo button to perform lah, right? You solo, we just hear that. Or we solo maybe a few channels, we only hear those tracks, only hear those channels. Now you can't do that in a live sound situation, right? Or mixing for audience. But then you just want to check, the tone of the bass guitar. You can't press a solo button and then pop, only solo, and suddenly the audience only hear the bass. Okay, so this is where actually you have a mode what we call a pre-fade listen. So what this does is that, right, if you have a PFL, when you press the solo or PFL button, okay, so this will send a pre-fade listen signal to usually if you're talking about an engineer, right, sound engineer, to only the headphones, right, and it doesn't affect your main stereo out. So there's always slight differences lah. So if you look in on a mixer next time, right, try to see whether is it purely a solo? There's a longer word for it, lah. We call it solo in place, okay? Or whether is it a PFL, whether it's a pre-fade listen. Okay, now, all right, a lot of technical stuff, okay? So the solo PFL allows you to isolate and listen to a single channel, right? Or sometimes a group of channels without affecting the mix, right? That's basically what a PFL button does, okay? So it doesn't affect the main mix. You just solo slash PFL that you can listen to, all right? You can adjust the tone, adjust the EQ, whatever settings, right, of the channel that you're listening to, and then it doesn't affect the mix. And obviously, you have the next component inside a channel strip, your channel fader, right, for adjusting the signal level. Now, in most regular situations, in most normal situations, right, signals that if you enter one channel, if you enter on a mixer channel, it's usually always routed to the stereo, or sometimes you call it the master lah, right? You sometimes refer to it. So depending on what brand lah, right? Whatever they label it, some call it stereo, some call it main, some call it master, right? And then interestingly, like I mentioned, right, last week we're talking about MIDI. The word master again, yeah, is being considered to be phased out lah. Okay. Now, so however, there are sometimes instances where you may need to control the level of more than a few faders simultaneously at the same time. Okay, so this is where the group, right, comes into play. Okay, right. So I give you a scenario, like example, right? If we record the drums, right? If you mic out the drums, sometimes you have, you know, 8, maybe more, tracks. And then if you want to control the volume, you want to bring down the volume of all of the drums in the mix. What how are you going to do it? You're going to have like well, if you have 8 or 10 mics, right? 10 channels for the drums, maybe you can manage lah, but your fingers will have to like that to bring it down, okay? Now it's so much easier, of course, to route and send all of these, the 10 channels, right? Or sometimes more, could be more. Send it to a group. Send it to a, usually it will send to be a pair, a stereo group. And from that group, just 2 faders control the overall drum balance, right? So it's obviously that's where groups are useful. And this is going to be useful as well, right? Even in DAW, right? Sending everything through groups and routing through it. Later, when you see my project file inside, right, you can always see I always arrange it into groups. I'll talk a little bit more about that, right? In when we get to week 5 lah, when we talk about mixing. Okay, so it is therefore possible to group or what we call sub mix. Okay, several signals prior to recording on a single track. Done this way, the group faders will control the combined levels of all signals simultaneously. Okay, so in this kind of situation, right, that is again where a mixer is sometimes useful. Let's say, for example, you have an interface, you bought an interface which got 8 inputs, right? Because usually it's either, 2, 4, 6, 8 lah, right? Like 8 analog inputs. Very rarely will you have an interface which has more than that, okay? You have 8 analog inputs. So usually if you want to go more, those have to be expanded using digital I/O. So if you come into a situation, so if you want to record drums, so let's think about, okay, you have your kick, you have a snare, you have, because you have 8, you have to think about how you want to you want to fit. So this drum kit is you have a kick, snare, you have hi-hat, you have 3 toms, okay? You have a ride cymbal and then you have overhead. So you got to decide kick, snare, hi-hat, tom 1, tom 2, tom 3, and then 7 and 8, right? A pair of overheads. Okay. So in this case, you kind of sacrifice the ride already. Okay. For example, in this case. So what if you want to have a ride symbol? What if you want to include a ride symbol? Or what if you want to have maybe 4 toms, right? If you get a setup, this drummer, 4 toms, man. How are you going to, how are you going to make all these channels fit into 8? You're gonna have to be a little bit creative lah, right? So in this case, what we will do is we will sub-mix the toms. Okay, so you sub-mix the toms, right? Either through a mixer, you mic it up, then you rug and you plug in all your tom mics into a mixer, and then you sub-mix them. Okay, you sub-mix them into a stereo. So this will kind of give you, it frees up another extra channel, another extra input, which you can input something else lah. For example, maybe if you're going to be recording whole band together, for example, so you may want to submix your toms to free up extra channels lah. Okay, so submixing, very, 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 very useful. Of course, if you have unlimited budget, wow, you can have all the inputs you want. Okay, but if you are not ever going to be doing more than recording drums or something like that, you won't encounter this situation lah. Okay, now this is the end of part one. We will move on to our second slide right after this. Okay, so we'll catch you back in a second.